Hi, welcome to this session in Science Paper 1 where we're going to create an end of month revision. So we're going to discuss about four major concepts in Science Paper 1. The first to mention with is going to be a wave. So it says the following is a diagrammatic representation of a wave. And then we have a question in this type. So if we have that is a wave in this particular way, I want you to understand that this number, which is here as a 4 and -4, is what can give us what we can call an amplitude. An amplitude is the height of the wave. Sometimes it can be defined as the maximum displacement of a wave. So the first question is define the term a wave. So we're going to say on this one, we're going to say a wave is a disturbance caused across a medium. So a wave is a disturbance caused across a medium. Then moving on, we have the question that says, from the graph above, determine, then one, the amplitude. So I said the amplitude is the height of the wave, so which means from 0 going to the turning point, or from here going to this one. The top part of the wave is called a crest, while the bottom part of the wave is called a trough. So which means our amplitude is 4, and we're going to say meters. Do not mind it appearing twice on the upper and lower regions. This means it's still the 4, except this 4 is just beneath 0, which is why it is a negative. So we just say 4 meters. Then from the graph above, determine the wavelength. How do we count or determine the wavelength? It is from the point of trajectory. So the point from where it is going to ascend upwards, we let it descend downwards up until to where it is going to create the same point. So this is supposed to be the distance of our wavelength. So we're going to say it started from 0 as ascending upwards. We let it come downwards until it starts to ascend again. So this is 6 and a 0. So the wavelength is represented by, that is a lambda. So we're going to say this is going to be 6 meters minus 0 meters, which is going to give us 36 meters. Then we move on to the last one, which says give one property of all electromagnetic waves. All electromagnetic waves are transverse waves in nature. That is point number 1. All electromagnetic waves travel in a vacuum, and also all electromagnetic waves move at a speed of light. So we're going to say, this one, we're going to say they all travel at a speed of light, which is 3 times 10 to the power 8 meters per second. So 3 times 10 to the power 8 meters per. Then we move on to question 2, which says the figure below shows an electric circuit connected to a 20 volts power supply. So which means in this regard, we have, that is a 20 volts, which should be on top of the battery. Then we have a 3 ohm resistor and a 6 ohm resistor. We have the ammeter, then we have the switch. Then the question continues and then says, calculate the effective resistance in the circuit. We can see the arrangement here that this is parallel because these are just in opposite to each other. So we're going to say the effective resistance is going to be R1 times R2, everything over R1, then plus R2. So which means for R1, we're going to have, that is a 3. So for this one, we're going to have a 3 ohm multiplied by a 6 ohm. Then this is going to be a 3 ohm, then everything plus, that is a 6 ohm. So we're now going to say 3 times 6, the answer is going to give us 18 ohm squared over 3 plus 6. This one is going to give us a 9, but when we are adding, we're just going to pick what is common. So 9 into 18, this one is going to give us with a 2 ohms. So hence here on the answer, we're going to say the effective resistance is going to give us a 2 ohms. Then from here, we move on to B. Calculate the current flowing through the battery. Current in physics is represented by I, and then it is given by voltage over resistance. So which means, do you have the voltage? Yes. That was the 20 volts they gave in the question. Over, do you have the combined resistance? Yes, it's a 2 ohm. So we're going to divide by a 2. So 2 into 20, we're going to get a 10, and then this one is going to be amps. So we're going to say the current here is 10 amps. And then lastly, it says calculate the charge in 10 minutes. Charge is represented by this, and it is given by the formula current times time. So I is current, T is time, except it should be in seconds. So current here is, that is a 10 amps multiplied by, what is the time? This is 10 minutes. 1 minute is made by 60 seconds, so 10 times 60. This is going to give us 600 seconds. So here we're now going to say 10 times 600. This is going to give us a 6,000. Charge is measured in coulombs represented by C. So here we're going to say the charge is 6,000 coulombs. Then we move on to question 3, which says the diagram below shows a pulley system under a simple machine. So on this one, it says the diagram shows a pulley system. I want you to firmly understand that the size of this effort is called, the size of this force is called the effort, and then the type of this force is called the load. So these are the two forces that we need to have on the diagram. Then it says define the term simple machine. So we're going to say a simple machine is a device used to make work easier. So we're going to say this is a device used to make work easier. This is a device used to make work easier. And then we move on to the second one. It says determine the velocity ratio. How do we determine the velocity ratio? We count the number of wheels. How are wheels represented under a simple machine? Wheels are going to be represented by circles. So 1, 2, 3, 4. No wonder the question said determine. So which means the velocity ratio is now going to be equal to 4. And since it's a ratio, it doesn't have units. Then the other question says calculate the mechanical advantage. So the mechanical advantage is given by the size of the load to the size of the effort. So here we're going to say, what is the load? The load was the downward force, which was 900 newtons, over the effort was 300 newtons. And then here we're now going to say Newton and Newton cancel, we cancel the zeros. So 3 into 9, it's a 3. So the mechanical advantage is a 3. Then lastly, we have a question that says calculate the efficiency. So when we want to calculate the efficiency, it means we want to calculate how accurate a machine can operate without making errors. So we always compare the mechanical advantage over the velocity ratio multiplied by, that is 100%. So the mechanical advantage is a 3 over the velocity ratio is a 4 multiplied by 100%. And if we punch this, we're supposed to get that is 75%, because 3/4 of 100 is 75%. Then we move on to question 4, which says the pendulum bob took 0.25 seconds to swing from A to C. So it took 0.25 seconds swinging from A to C. I want you to understand that a pendulum bob moves around this 4 times. So which means it swings from A to B. It also swings from B to C. It also swings from C back to B, then B back to A. So a pendulum bob makes about 4 swings. So it makes 4 swings. So 1, 2, 3, 4. So it makes 4 swings. So if it makes 4 swings, this is what's going to make what we can call an oscillation. So if at all there is the question that says define the term oscillation, we're going to say this is the number of swings made per second. Always know a pendulum bob makes about 4 swings. So which means in this regard, if it moves from A to C, it simply means it only moved 2 times. 1, 2. So the number of oscillations should be 2 over 4 because it's not complete. So define the term oscillation. So to define the term oscillation, we're going to say this is the number. This is the number of swings made per second. This is the number of swings made per second. Then B, calculate the period of the pendulum. The period of the pendulum is the time taken for a bob to make an oscillation. So the formula is T equals to the time taken over the number of oscillation. So how long did it take? There was a specification. So it took 0.25 seconds. Then how many swings did it make? 1, 2. So it's a 2 over the 4 complete swings that it does make. So which means here we're going to say the time is 0.25 over the number of oscillation is 2 over 4, which can be written as 0.5. So 0.5 into 0.25 is going to give us 0.5. Then this one is going to give us seconds. So on the answer, we're going to say T equals to 0.5 seconds. Then moving on to the last one, which says calculate the frequency of oscillation. So frequency is just the opposite of the period of the pendulum. Remember I said period of the pendulum is the time taken to make, that is the number of oscillation. So the frequency is the number of oscillation made per second. So we'll switch the formula. Number of oscillations made per second. So which means number of oscillations. What are the number of oscillations? 0.5 over what is the time taken. So for this one it is 0.25. So which means 0.25 into 0.5, we're going to get a 2. So frequency is measured in units called hertz. So therefore we're going to say frequency equals to 2 hertz. I hope this helps you to prepare adequately for an exam in trying to see that you image victoriously, and it boosts your confidence.